Welcome participants who are connected through our YouTube channel as well as through this WebEx. Welcome to this third session of the day 2 of this webinar. I would like to call our speaker, Dr. Krishna Giri. He is scientist in Rainforest Research Institute, Jorhat, Assam, Indian Council of Forestry Research and Education, Ministry of Environment, Forest and Climate Change, Government of India. Sir, I would like to start. You can start, sir.
Okay, thank you, sir, and very good afternoon to all of you and respected organizers and dear participants. So, with this, I will start my presentation on today's topic. So, first, I will share this. So, is it visible, sir?
Yes, sir.
Yeah, can I start?
Yes, sir. You can start.
So, dear friends, yesterday I discussed about the forest types of India and the role of forestry sector in carbon sequestration, role in global carbon cycling and different carbon pools, and its role in climate change mitigation. So today I am going to discuss a different scenario in our country, that is shifting cultivation practiced in Northeast India and some other states of India, which is very peculiar kind of practice for the subsistence of people. And though this is the only source of subsistence for various tribal communities inhabiting in the hill regions of Northeast India, but there are certain implications in terms of this climate change. So I will highlight the peculiar characteristic of this shifting cultivation. I hope most of you might have heard about this zoom cultivation or shifting cultivation, but not knowing much, being a from a background of engineering sciences. So today I will show the pictures. This presentation is more of pictorial one. Lots of photographs I will show, I will share. Then I will show you the practice in this region. And at the last, I will share some data on its implication in climate change. Because due to this large scale deforestation for this agricultural system, so we lost significant amount of carbon from the system. So at that, under such circumstances, this forest again become a source of emission rather than sink. Yesterday we talked about the sink. So outline of the presentation is shifting cultivation, which is also known as zoom cultivation in Northeast India. So there are certain benefits of this cultivation system. Then problems associated with shifting cultivation I will highlight, which are the mainly deforestation, biodiversity loss, carbon emission, then direct implication to our climate change. And at last, I will discuss few points about its alternatives, which are being developed now and which are the called upon, because this is now time need of the hour. that this shifting cultivation alone cannot be acceptable. So we have to think about the alternatives in order to mitigate climate change. So coming to the definition, this shifting cultivation is a English term. It means shifting from one place to another place for cultivation of crops, that is agriculture system. This agriculture system is practiced since Mesolithic period, means you can say that it is prevalent since 900 years ago, centuries ago. We can say millennia. From the millennia, these tribal communities in northeastern states are practicing this cultivation practice, and this shifting is called because here the peculiar characteristic is land is rotated rather than crops. In other parts of our country, you can say about the Uttarakhand also, we rotate the crop in a particular land or agricultural land rather than land. We rotate the crops. Here is the scenario is we rotate the land rather than crops. So after cultivation of 2-3 years in a particular piece of land, hill slopes, that land is left abundant, and the people shift in another forest area for cultivation. That's why it is called shifting cultivation. Popularly, it is known as jhum cultivation in northeast India. The meaning of jhum is arises from an Assamese word that is collective work. Jhum means collective work. So farming communities of a single village are collectively doing this jhum cultivation in a landscape. So there are temporary demarcation of the land allotted to them for cultivation, but there are no permanent demarcations. That's why it is a collective work, jhum. So beside this northeast, there are 8 states in northeast India, except Sikkim. This practice is dominant in all the states, all 7 states, but not in Sikkim. In case of Assam, only 2 districts, 2 hill districts of Assam are known for jhum cultivation, and rest of the Assam is in a Brahmaputra floodplain or a valley region. So it is prevalent only 2 hill districts. But in case of Nagaland, Arunachal, Mizoram, Manipur, and Tripura, it is predominant practice in hill states. These states are hilly. So other than this northeastern 7 states of northeastern region of our country, Andhra Pradesh, Odisha, MP, and Jharkhand. These in these states is also this practice is prevalent, but in very lesser extent. So the farming communities, the practice is known as jhum. As I told you, jhum means the collective work, and the people engaged in this type of agriculture practices are known as jhumia farmers. Literally, we call them Jhumiaj. So, other than our country, so this primitive form of agriculture is practiced in tropics of Southeast Asia, the Pacific, Latin America, the Caribbeans, and Africa for the centuries. So, this in this agriculture indicates the evolution of our civilization. From that hunting and gathering processes, the first agricultural form evolved on this earth is this shifting cultivation. After that, slowly the human evolution took place, and different advancement and agricultural practices were developed in the world. But this is the earliest one agriculture practice after hunting and gathering by the primitives of this earth. So you can see there is a total forest area of 17.2 million hectare in northeast India. बाद में देखूंगा इसको, ठीक है. So that is around 25% forest area of our country. So you can see the graph in which the extent of shifting cultivation is shown. So this data is based on the statistical yearbook published in the year 2014, but this process is very dynamic. So getting actual area under this shifting cultivation or zoom cultivation is very difficult. However, using this RSGIS techniques, we have able to uh, demarcate the areas under shifting cultivation based on satellite imagery analysis and field data records. So you can see in Arunachal Pradesh, Assam, it is maximum in Manipur, then Meghalaya, Mizoram, Nagaland, and Tripura. Earlier, this Tripura state was also prevalent in this agriculture system, but in the recent decades, the people have adopted other land use sectors. As already yesterday I mentioned that Apollo word, agriculture, forestry, and other land use sectors. In these other land use sectors, other beneficial crop systems are included, like tea husbandry, then rubber plantation, then pineapple cultivation, then broom grass cultivation. These are the other land use practices. So now people are adopting these cash crop based or more beneficial land use as compared to this primitive form of agriculture. Therefore, the area is less in Tripura now. So this current trend in shifting cultivation research says that the area under shifting cultivation is decreasing. There are reasons for decrease. One is that the older people, older generation are still prefer this agriculture system because it is bound with their socio-cultural aspect. So, but the new generation is not going to take much interest in this farming system. That's why the area under shifting cultivation is decreasing. And at the same time, development of new land use policy by various governments of this region and adoption of different land use as mentioned, are the reasons for decrease in shifting cultivation. So this is decrease is very good for us in this climate change scenario because there are serious implications too. And the recent mapping analysis done by NESEC, ISRO organization is there in Meghalaya. So it reported that there is 5% area is under still zooming cultivation in northeast India, though the total geographical area of this region is 7.9% of our country. Out of this 7.9% of northeastern region, still 5% is under shifting cultivation in various form, either in current zoom, which is being cultivated, or in fallow lands of different varying length. Zoom fallow, current zoom fallow, then longer zoom fallow based on the years of abundance. So this is the current scenario. So this graphical representation depicts about the practice, how it is done. First, you can see the natural forest. Earlier, it was the primary forest. Then after slash and burn or climax forest, you can say these natural forests are slashed in the hilly region by the farmer. After slashing, the biomass is burned in the field and land is prepared. After land preparation, crop cultivation is done mainly 1 to 3 years of duration. After 2 3 years, the productivity and soil fertility of that land is lost due to several reasons because this practice is prevalent in steep hilly regions. So due to intense this region is high rainfall area. So after 2 or 3 years, the due to leaching of nutrients and surface runoff and the soil erosion, the topsoil fertility is lost. Therefore, people shift from one place to another place, and it is called shifting cultivation. So the perfect season for this practice is started from the winter season. Nowadays, people are clearing the land, slashing the forest areas, then allowing the biomass to dry, and they will burn it in the month of January and February. After burning, so land preparation starts and the crop cultivation starts during the first shower of the pre-monsoon rains. You can say in the month of March onwards. So after 2 3 year of crop cultivation, the land is left to regenerate again. That is called fallow zoom land, abundant zoom land. That land is fallowed, and the people shift in another adjacent forest area for cultivation of similar kind of practices or cultivation of crop. So the traditional zoom fallow of older days was 15 to 20 years. Means 15 to 20 years that land is allowed to regenerate naturally to convert into a secondary forest because this time is very much sufficient to regain the soil fertility and biodiversity of that region. After that, people revisit this area again. So this is one zoom cycle. From first slash and burn to the next visit, that is one zoom cycle. So this zoom cycle of earlier days was supposed to have 15 to 20 years. Nowadays, due to increasing population and decreasing land availability due to forest deforestation and land degradation, this older long length zoom cycle has been reduced, shortened into 4 to 5 year. So this 4 to 5 year zoom cycle is not sufficient to regenerate the soil fertility of that land. That's why this old age farming system is becoming unsustainable and unproductive. So this is becoming a critical scenario in this state. So after this zoom, regeneration of zoom fallow is again allowed. Then this ultimately that the forest after 15 to 20 years is called secondary forest. Secondary forest means first it was a primary forest, natural intact forest. After human intervention, it was again regenerated into secondary climax forest. So in between now, due to this shortening of zoom cycle, people are adopting some other measures to cope up with the system, to adapt in the situations. So along with the soil exhausting crops, nutrient exhausting crops, farmer are growing, introducing the mixed cropping system in which soil enriching crops like legume pulse crops are being incorporated in the field, so that that zoom land can be used after 4 or 5 years of cultivation again. So that is called short zoom cycle. In case of our Uttarakhand, if you remember, we also do this mixed cropping system. In a particular piece of land, first paddy is cultivated, followed by this wheat, then mustard. In along with paddy, we used to cultivate maize also. Then after that, you might have seen that in the third cropping season, the cereals, millets, particularly millets having low nutrient requirement, along with mixed crops, pulse crops, that urad, then gahat, then soybean. These are the major components with this millet, barnya millet or finger millets. You can say bajra and those. So the concept behind is that to regenerate the fertility, because during older times there was no access and availability of synthetic fertilizers in hill areas. So due to this, the farmer used to apply permeated manuring is the process for soil fertility enhancement, along with this crop rotation. So in case of our Uttarakhand and other states of India, crop rotation is in practice, but here is the scenario is just opposite. Land rotation is in practice. So this is all about this zoom cycle and a single cycle. Then there are certain benefits. This region is dominated by more than 200 tribal communities. So this region is a culturally diverse region in the world, and this region is also known as one of the biodiversity hotspot of our country out of two biodiversity hotspots. So this region is culturally diverse, and these diverse cultural tribal communities have their diverse farming systems. So different names are there: Zoom farming system, then Javo farming system, then tree-based farming system, then improved zooming. As I told you, that now people are incorporating soil enriching crops along with their nutrient exhausting paddy and maize and other crops. So there are certain prototypes in the different states, even within one village, within one district. There are certain villages, and the variability among the cultivation practices are different as per their cultural characteristics. So this is the peculiar characteristic, and the region is dominated by and more 200 tribes are told, and more than 100 tribes, indigenous tribal communities are practicing this shifting cultivation as a source of subsistence. And this is the only source of subsistence in this hilly region, because this rigorous mountain terrains. So there is no immediate alternative of this shifting cultivation. That's why it is in work till now. So sole source of subsistence, though farming communities are producing number of a variety of crops in a single land, means multiple nutrition requirement of these communities are being fulfilled from a single field. So diversity of crops is very high, and you can say, and at a single time in a single crop field or a particular specific location, about 15 to 60 crops are grown in a single field in the first year. So this is only because of the soil, to explore the soil nutrients, because when this vegetation is slashed and burned, the first flash of nutrient gained by soil is utilized by these farming communities very scientifically. In the first year, the crop diversity is more in order to utilize the nutrient properly, because in the second year onwards, the fertility, and due to soil erosion, the fertility and productivity start going down. So the economic and energetic efficiency is very higher as compared to our conventional agriculture system, because input to output ratio is much beneficial. In this case, lower inputs are required and higher benefits are gained. Multiple nutrition source. but the cost of forest slash and burn is not included in this. This ecological energetics was first studied by the renowned ecologist Professor P.S. Ramakrishnan. He has mentioned that the energetic efficiency of this shifting cultivation is far higher than the conventional agriculture, which is settled agriculture. So it ensures food, protein, cereal, oilseed, fiber, firewood, etc. requirement from the single field. There are multiple benefits and multiple requirement of the farming communities are fulfilled. And going ahead, you can see the photograph now, also more of the photographs. So this farming practice is followed in a cultural manner. In a cultural manner, because the farming communities celebrate different festivals at the beginning of this cultivation. When they start the cultivation, during the cultivation phase, and after harvesting, they celebrate several festivals in a cultural and traditional manner. You can see in these photographs, after preparation of land, how they are having the feast, a community feast. So this is the reason for this culturally bound. This cultivation system is bound to their cultural system. Therefore, it is prevalent. This is a Angami tribe in Khonoma village of Kohima district. So how they are celebrating their beginning of the crop season. You can see. So you can see the another photograph in the left one. The land is slashed. The landscape, total landscape is slashed for preparation of land, and land is almost ready. And the another one, you can see the paddy crop. So the Zoom means collective. The farming communities are collectively practicing this cultivation in the hilly slopes, forest areas. So you can count the huts, and you can say that how many families are practicing shifting cultivation in this region. One hut indicates one family. So the land tenure system here is a peculiar one. The land is owned by the communities rather than government. They have privileged right on their land, access land use, and the land is not occupied a single family. The land is under the control of a village headman. It is technically called here a gaon budha. So he proportionately divide the land to all the families in his village, and that is equal distribution without any dispute. So that people of that particular village, one village, do this practice in a one region. So you can say in a district, if there are 10 villages, so 10 village have 10 different shifting cultivation landscapes. So this is all about this shifting cultivation. Then in Okha district of Nagaland, you see the Jhum field. The vegetation has been already slashed. Few trees are kept in the field. So after burning, the crop is in growing phase. That is paddy, and you can see the wooden logs are kept in different locations from the upper side of the hill to the lower side. This is called the log bunding method. These logs, tree logs, are used for bunding the soil to prevent soil erosion. So this is another type of variant of shifting cultivation. So this log bunding is used for soil erosion control. And you can see the overview of different landscapes and different crops. I told you that along with this paddy and other staple crops, they used to cultivate these legumes. Legume have potential of nitrogen fixation in a association of symbiotic relationship. So in symbiotic associationship, these crop help in nitrogen fixation and enrich the soil fertility. So these crops are collectively called as soil enriching legume pulse. So another, you can see another photograph in Zoom cultivation in Mokokchung, Nagaland. So in left one, you see the forest land has been deforested and prepared for cultivation, and in another you can see the this tomato and potato vegetables and crops. Many crops are grown in one field. So some of the photographs from our experiments on these Zoom fields to increase the productivity using plant growth promoting rhizobacteria, and you can see the sites where we have done our scientific intervention to improve the productivity with the help of plant growth promoting rhizobacteria. So you can see some of more photographs of harvesting the samples for yield analysis. Then you can see the Zoom cultivation in Manipur. In the left one, you see the greener part is abundant Zoomland, fellow Zoomland. which were earlier cultivated. Now it is left for regeneration. So another, the right side one is recently prepared for cultivation, and in the another photograph you can see the upper region of this hill is occupied by the bamboo species, and this lower region, this jhum farm is now being developed into an agroforestry system. The green, these saplings are of Malaina arborea, one timber yielding tree species, and there is the paddy straw. The paddy is already harvested, so now the Zoom cultivation is being converted into agroforestry system or integrated farming to make it more profitable and environmental friendly, etc. So you see in another picture, you can see the landscape view of valley cultivation. Valley means this in the lower region where the excess water is available for irrigation. The farming communities cultivate paddy, which is commonly called here is a wet rice paddy cultivation. Wet means these valley region, these fields are always filled with water annually. There is a annual water availability. In hilltops, you can see the clean shaped areas or slashed areas for jhum cultivation in this upland cultivation, you can say, and some of the forests are still intact after cultivation of 1 or 2 years in these slashed areas. Then farmer will shift in these natural forest areas, and this area will be left abandoned for regeneration. So this one picture is showing two type of cultivation: hill region shifting cultivation, in valleys wet rice cultivation or wet paddy cultivation system, which is very much prevalent in Northeast India. So another, you can see the photographs of shifting cultivation is steep slopes and very dangerous hills of Mizoram state. You can see the areas are slashed, and some of the areas are left abandoned for regeneration, and some are cropped, and you can see the closer view, the cultivated areas in this steep slopes. This is from Mizoram. Then coming to the topic shifting cultivation and climate change, how this shifting cultivation is contributing in greenhouse gas emission, or we can say carbon dioxide emission. So there are certain implications beside its cultural and socio-economic importance. There are issues. That's why nowadays, instead of this slash and burn agriculture, either the improved zooming is being preferred, being suggested to the farmer, or integration and adoption of agroforestry. Also other land use are being suggested them in order to control this greenhouse gas emission from this agriculture sector. So the issues are deforestation. I already explained yesterday. Deforestation means conversion of forest land for non-forest purposes. Here the deforestation is only for agriculture practices. Then soil erosion is the another issue. Once the slopes are slashed, after that that soil has no support of plant roots. Therefore, due to high rainfall, the surface and topsoil, fertile topsoil, lost from the system. So thereby this zoom cultivation is some is negative from this point of view. And another important implication of this soil erosion is siltation of Brahmaputra river, because Brahmaputra is in a floodplain of Assam, and from all the most of the hill states of northeast India, the rivers are finding their way into the Brahmaputra. So along with those river water, this huge amount of fertile soil is being carried, and it is the increasing sediment load in Brahmaputra river. So this is another challenge. Then biodiversity loss. We can say that if once a forest, diverse heterogeneous forest is deforested, so lots of species will be lost. Or some of the species may be of medicinal and economic importance, and which may be some of them may be endangered or threatened. So from this conservation point of view, we can lose the threatened and critically endangered species through this process. Then carbon emission, there is a burning of huge biomass. Once a forest area is cleared, maximum biomass is burned in that in situ, means on the fields, and certain portion of that timber and firewood is collected, but most of the that slashed biomass is burned in the field itself. So that is the source of carbon emission, followed deforestation. So land degradation, once the topsoil is lost due to the erosion and this deforestation, ultimately the productive capacity of the land will be lost. So that is called land degradation. So you can see the biodiversity loss. Again, I am showing the photographs. You can see the intact forest area in this extreme end. But here that similar kind of forest has been slashed for cultivation. So from this heterogeneous forest, many species are lost and many important species are lost. And this in this way, this shifting cultivation is not good for biodiversity point of view. So we are losing biodiversity. So you can see the burned area. This much area is slashed and burned, and you can see the diverse heterogeneous forest. If it will be extended, this slash and burn will be extended in this greener part or diverse dense forest areas. So what will happen to these forests? Where these will go? These forest and the diversity of this region will be simply burned out. So this biodiversity conservation point of view, this farming system is not sustainable at all. You can see the slashed forest, and this land is now ready for cultivation. So what is the fate of this slashing of the forest? You can closely see here in this photograph, in these photographs. So some of the statistics about these shifting cultivation, what is happening. So it is estimated that there is around 56.9 megagram per hectare per year of topsoil loss. Means tons per hectare. Megagram means this is equivalent to the metric tons. So 56.9 tons per hectare per year topsoil is lost due to this shifting cultivation, slash and burn. And at the same time, estimate says that 7.1 tons per hectare per year nitrogen is going to be washed from the top layer of soil. So nitrogen is the most important major nutrient for plant growth. Without this nutrient, we cannot think about agriculture or forestry. So this should be available in a sufficient amount in the soil. If you are losing this much of nitrogen, so you can say that the cost of synthetic nitrogen production is very high. And moreover, in these hill areas, these chemical fertilizers are not applied. This farming system is a kind of organic farming. Therefore, that Professor Ramakrishnan sir has mentioned that the energetic efficiency of this farming system is much higher than the modern agriculture system, where we use synthetic fertilizers and pesticides. So potassium loss is around 4 tons per hectare per year estimated. Then annual forest slashing in some of the states, we have got latest statistics. So in Manipur, 44 to 55 square kilometer of forest area is deforested, slashed per year, per year. So you can imagine, if 1 year in a single crop year we will deforest this much land, what will happen to the biodiversity and this carbon pools. Then in Mizoram it is more higher, because in Mizoram maximum population is dependent on this shifting cultivation. In Nagaland also, as compared to the Manipur and Manipur, nowadays Nagaland and Mizoram are more area under in more shifting cultivation. So coming to the carbon point of view, the soil carbon estimates made by us says that you can see the native forest area. If there is 45 tons carbon in the soil, and if it is this area is slashed for shifting cultivation, definitely this carbon pool will be lost. And you can say that after 5 year of fallow, after cultivation, this is around 50% less than the natural forest. And after 10 years, it is gradually increasing. The increase is not rapid in the carbon stock of soil carbon recovery. So you can see in all the figures, the forest carbon stock is very much higher than the Zoom fallows, because in the Zoom fallows, initially the weed species and the bamboo species occur as a pioneer species. So in this these fallow lands, this soil carbon stock is disturbed. That is, carbon cycling is disturbed in natural forest due to the heterogeneous species. So and leaf litter decomposition and this humus formation, always soil organic carbon is higher. But in these areas, the diversity is less. If the diversity will go down, definitely the carbon stocking will also be changed. So you can see from this table what is the actual soil carbon stock in the forest, natural forest or intact forest, and what is the fate of this shifting cultivation. This point of view, this is the contributor of greenhouse gas and climate change. So you can see another photograph in vegetation. You can see that in the native forest, this much tons per hectare carbon is stored in above ground biomass tree part. and this much is in below ground root areas. And as compared to the fallow land of 5 years and 10 years, what is the amount? So it is far lower than this natural or intact forest. So we can say that due to this shifting cultivation practices or slash and burn, we are losing more and more permanent carbon stocks. So we are contributing in climate change. So these are the implications of shifting cultivation in climate change. So this is a contributor, net greenhouse gas emitter or contributor in climate change scenario. Therefore, now this cultivation system is not being preferred. There are divergent views on this shifting cultivation. One view abruptly says that this is narrative one, this is not good for the environment. The another school of thoughts says that this shifting cultivation is culturally rich and crop diversity, agrobiodiversity is very rich and the only source of subsistence. So that another group of people support this agriculture, but due to the lack of other alternatives, immediate alternatives, this is still being practiced. So you can see the biomass burning and carbon emission. So this is the fate once the huge biomass slashed and burned. So we can say that how much carbon is going to add in the atmosphere. This is the issue of zoom cultivation and climate change. You can see the completely burnt plots before cultivation of crops. So this is happening with the forest areas, and this in this region the maximum forest areas are under the control of communities. In case of Nagaland, out of 100% forest area, only 10% is under the control of state forest department. 90% and the forest land is controlled by the communities through the article 71 gives them article 71 of Indian constitution gives them the privileged rights of land use, so they can manage their land as per their convenience. So this is the issue, that's why this cultivation is still in wake. So coming to the soil erosion, if the hill slopes will be slashed and clean shape for this cultivation, when these areas will be exposed to high rainfall, so definitely there will be huge amount of soil erosion as shows the estimates made by scientific studies. Once the land is this topsoil will be lost from the land, then the land will be called degraded land, means the biotic potential of that land will be lost. So this is the example of soil erosion and land degradation. So coming to the soil organic carbon projections made by the researcher of Mizoram University, you can see the different land usage and the carbon loss. So first one is forest to shifting cultivation. Forest to shifting cultivation, around 5.5 to 6 tons of carbon per year is lost from the soil. So soil is the largest carbon pool. It holds double amount of the carbon present in the atmosphere. So if it will this shifting cultivation will continue, so what will happen to the carbon sink? So from forest to wet rice cultivation, there is very less loss of carbon. This wet rice cultivation, there is no slash and burn. It is a permanent. Forest to home garden. If a forest is converted to home garden, though the loss is there because forest is being converted into home garden may be less diverse than the forest or having less carbon, but the height is less. So forest to bamboo, if the forest is converted into bamboo, the loss will be again more. And forest to grassland, the loss is more than the wet rice cultivation and home garden. And forest to oil palm plantation, again the loss is more because this oil palm plantation in Mizoram has degraded the land, and this is ecologically not suitable viable option. So that the under this palm oil plantation other vegetation hardly survives. So this is creating the disturbance in the net ecosystem functioning of that particular region. Similarly with this rubber cultivation in Tirpura, earlier the Tirpura was the in most of the hill districts there were shifting cultivation. Now this shifting cultivation has been replaced with the rubber cultivation. So rubber cultivation is also not too much good for ecosystem point of view, ecological security and ecological sustainability point of view. And you can see other example, forest to teak. If a forest is converted to teak plantation, again there will be loss, but it will be lesser than the oil palm. So these are the examples, studies by proven studies. And our study in Meghalaya, myself and my colleague did this organic carbon modeling in different land usage. So you can see that first one, the blue line is zoom to rubber. Zoom to rubber. This carbon stock, this loss of carbon is not too much rapid. It is steady. But in case of zoom to tea, it is increasing. Means zoom cultivation to tea cultivation of land use system. If tea husbandry is there, this carbon stock is increasing. Means rubber tea gardens are conserving the soil carbon. So another scenario, continue zoom. If the zoom will be continued in a particular landscape, thus there is a gradual decrease in the soil organic carbon stock. So this much carbon is going to be lost from the soil, and it is directly going into the atmosphere in the form of carbon dioxide. So zoom to zoom 7 year. If a zoom 7 year to zoom after 7 year of fallow land, if you will do, there will be certain ups and downs. Sometime it will be increasing, sometime it is decreasing. So this is not going to make some positive impacts on this carbon sequestration point of view. So that is also not preferred. So here, this as per this study, we can say that adoption of tree husbandry instead of this shifting cultivation is a good indicator for climate change mitigation from this sector. So alternatives nowadays, various other alternatives I have already mentioned. This other land use sectors are being practiced, but the most attempted land use system across the globe is agroforestry. Nowadays, as much as hue and cry is created due to this climate change, and at the same time, this agroforestry is being promoted in the similar pace. That is in the hot topic. Agroforestry is the hot topic of the this time. So this agroforestry concept was first given by an American geographer, J. Russell Smith. In his the book, Tree Crop, A Permanent Agriculture, he pointed out the importance of this agroforestry in 1929, means this 20th century. But at that time, our world population was facing this food grain crisis. So hunger crisis was there. So at that time, the farming sector was aimed to boost the productivity to feed the growing population, so that green revolution took place. So under the scenario of green revolution in 1960s 70s, so this tree crop, a permanent agriculture, was highly neglected. But later on when this excessive use of synthetic fertilizer pesticide degraded the soil health in arable lands, so again this concept of this Russell Smith was recognized and found that it is a very much sustainable farming system. Therefore, now this agroforestry is being uh, developed in various regions of the world, not only our country. So now intentional perennialization of arable land is the target of the scientific community to get multiple benefits from one farm, and to conserve the carbon sink, to enhance the carbon sink in order to uh, fulfill our commitment to UNFCCC in the form of NDC, nationally determined contribution of having 2.5 billion to 3 billion of additional carbon sink. So this area, degraded land restoration and this agroforestry, these are the two prime areas of our concern in order to mitigate the climate change and create additional carbon sink as committed. So it contributes to food, nutritional and environmental security, great potential to restore degraded landscapes. We have some degraded landscape. Our population is increasing, so we have to produce sufficient food grain, but we cannot expand the land area. Land is limited with us. So with increasing population, we cannot expand our land for cultivation. Therefore, our target is to restore the degraded lands through agroforestry system or integrated farming system. So it is the target of this bone challenge also, to restore the degraded land areas. And it also aims at helping farmers to increase the productivity, profitability and sustainability of their land. It helps, and it is proven now that agroforestry is more productive, sustainable than the solo agriculture, monoculture, the modern agriculture. Now it is considered a problem solving science. This agroforestry has been considered a problem solving science and can both sequester carbon and produce a range of economic, environmental, and social benefits. So this agroforestry is the best suitable and viable alternative, immediate alternative of this shifting cultivation and climate change mitigation and adaptation mechanism. So there are certain variants of this agroforestry system. I am not going to discuss much about these. These are the combinations based on crops, horticulture crops, trees, and all. So some of the examples. This is one example of Elnus nepalensis elder-based agroforestry system in Konoma village. This elder is known as Utis in Uttarakhand. It is found in the subtropical to subtemperate regions, higher regions. This tree species is utilized here for soil fertility enhancement. So you can see these, the older trees are about more than 100 years old. So the farming communities pollard the trees from this much height, 2 to 3 meter above the ground, and after pollarding, the wood is collected for firewood and timber, and the leaves and twigs are burned in the land. This land to enrich the nutrients. After that, vegetables and crops are cultivated, and this land is left abandoned for 5 years after 2 years of cropping, and they shift to the another place. And the peculiar characteristic of this Elnus nepalensis is it is a nitrogen fixing tree species. It fixes atmospheric nitrogen in association with a symbiotic bacteria, actinobacteria called Frankia. So this utilization of this Elnus trees, Elnus nepalensis elder trees in the Jhum field in Khonoma village is a unique agroforestry system in this region. This tree species is found in our Uttarakhand also, but it is not being utilized like this. So you can see another this again elder and large cardamom based agroforestry system very much popular in Sikkim. So these elder trees are used for soil fertility enhancement and as a shade tree because this the large cardamom is a shade loving crop. So this is a profitable and very well proven sustainable farming system in Sikkim. So another that smaller other farming system like pan beetle and areca nut and home garden systems in northeast India, these are also being replicated in the Zoom fields to reduce the impact of shifting cultivation and carbon emission. So in conclusion, what I would like to say that shifting cultivation is a fine example of how the production system has been adapted to an ecological niche because this region is very this difficult terrain. There are steep slopes and no permanent agriculture is possible. So far, this is a adaptation mechanism in this rigorous terrain, hilly areas, and source of subsistence. Shifting cultivation is a scientific system which tries to capture soil fertility nurtured by forest growth. It is said by the Professor Ramakrishnan, who was the pioneer ecologist who work in the shifting cultivation system. Shortening of zoom cycle is an alarming and challenging issue at present because the older zoom cultivation system was much sustainable than this shortened zoom cycle. So this has reduced the productivity and fertility, thereby the profitability is decreasing and minimum burning operation are now preferred. Now it is being advised to them that though they can slash the vegetation, but the burning should be minimum so that climate smart agriculture or minimum tillage or minimum burning agriculture can be preferred. So shifting cultivation needs transformation, not abolition. It is mentioned in the recent Niti Aayog report on shifting cultivation. There also they have pointed out that this shifting cultivation cannot be stopped, and there is no other options as compared to this. But it need to be transformation, as I mentioned that minimum burning and the tillage is minimum, but we have to adopt certain other measures, soil erosion control measures, and we have to improve the zooming system so that transformation is required, not abolition. Abolition of this shifting cultivation means we are going to abolish the cultural diversity of this region and the subsistence of farming community. Therefore, it is required transformation in tune of climate change mitigation point of view. So acknowledgement, I would like to acknowledge all the information sources, our director sir for permitting me to deliver this lecture, and organizers from Nanhi Parisivant Engineering Institute of Pitharagarh, then young participant who are the main target group of this 3 days webinar on climatology and meteorology. With these words, I conclude here. So if there are any queries, let us. Thank you.
Thank you, sir, for sharing your valuable knowledge. Friends, any questions, any queries? You can raise and we'll unmute you.
What are the effects of mitigation on shifting cultivation? Means people moving away from village. No. Mitigation means people are not moving away from village. Though for cultivation they move away. They are living in their uh, villages, but for cultivation they go to the forest areas, and there they are making the huts for working time. This practice is this cropping season is during monsoon, so those huts are for their working time. If there is some rainfall, they take rest inside those huts, and they are moving away from their original village to the forest areas for cultivation, but later on they return back to their homes. And in terms of mitigation means we have to reduce the extent of shifting cultivation. If we will reduce the slashing and burning of the natural forest, it means we are directly reducing the emission of carbon dioxide from the shifting cultivation areas, and through minimum burning of biomass, we are going to mitigate the impact of climate change. If our concentration of this carbon dioxide will increase in the atmosphere, then it will aggravate the global warming and greenhouse effect, and temperature will increase. So if you will reduce the concentration of carbon dioxide in the atmosphere through the minimum burning or decreasing the extent of shifting cultivation, it means we are doing the mitigation activities. Oh, here word is the migration. What are the effect of migration on shifting cultivation? Yeah, sorry, I was reading it mitigation. Due to the migration, this shifting cultivation extent of shifting cultivation in Northeast India is decreasing. We have also personally observed this, because I am working on shifting cultivation areas in Nagaland for the last 7 years. So what was the farmers view, that their new generation, they are going for higher studies to Delhi, in other Dehradun, in other states. So the older people are doing the shifting cultivation, but the young generation, they are not much interested in this shifting cultivation. Therefore, the impact of migration is positive towards the reduction in the area extent. As I mentioned in one of the slide, that nowadays this shifting cultivation extent of shifting cultivation is decreasing. The reason is that the younger generation are migrating from these hill regions to the other states for higher education, for jobs, and for other business purpose. So shifting cultivation is decreasing. New generation is not much interested in this primitive farming, but the older people have their cultural beliefs, and their cultural and their emotional attachment with this farming system. Therefore they are still doing this practice.
And no question, participants. I think we have covered questions, sir.
Okay, thank you, sir.
Thank you, sir, for giving us time.
Okay, thank you very much for giving me this opportunity to share my views, my observations on this shifting cultivation and climate change with you all. And with
Thank you,
these
sir.
words, I'll take your leave. So I have to join some other meeting. So I'll quit the
Yes,
meeting.
sir.
And I wish you a successful webinar for the coming days, means tomorrow also, and the next session and tomorrow session. I wish the best. I wish my all the best to you all.
Yes, sir.
Okay, thank you.
Thank you, participant. Now it's time to move ahead to our next speaker, Dr. Bikram Singh. He is the director in Meteorological Center, Dehradun. So over to you. Bikram sir.
Hello.
Hello sir.
Yes, we can start.
Yes sir.
This is visible.
Yes sir, it is visible.
We can start.
Yes sir.
Okay. Good afternoon to all. And I thank Nanni Simant Engineering College Institute for giving me this opportunity to deliver a lecture on weather and climate, and under that, monitoring and prediction. So how we do the weather monitoring or climate monitoring, those things we will discuss. And then how we do the prediction also, weather prediction. So those things also I will discuss. So you can go ahead, you can start, I think. So first of all, weather and climate as a definition, if you see, weather is concerned with detailed instantaneous state of the atmosphere with day-to-day evaluation of individual synoptic systems. And if you want to define the weather, so you can say it is the complete state of the atmosphere at a given instant. So for example, if you see the weather parameters during morning hours, they will be different what they will be during the noon hours. And similarly, by evening, they will be different. So weather at a particular instant, at a particular place, is the sum total of all meteorological parameters, variables at that instant. So like you have temperatures, you have atmospheric pressure, or you have rainfall activity or cloud coverage, or it is clear sky. All these things will form the part of the weather at that particular hours when you are observing. And it keeps on changing. It is a very dynamic one, so it keeps changing. Then as a definition for climate also, what we call the climate. So climate can be considered as the average weather conditions over a place or a long period, or you can say with some measures of variability of its elements with information on the occurrence of extreme events. So climate is the average weather conditions. So average weather condition, it should be something for 30 years or more, a continuous data set. Then you can find the different parameters. You can take the average for that long period, 30 years or more, and then you get a normal value. But normal doesn't mean that everyday temperature will be like the normal. So temperatures, as an example, it keeps varying. You may have average temperature for the project, minimum temperature, suppose Dehradun it has 5 degree, but sometimes you see it is 7 degree, other day you find it is 3 degree also, or sometimes 5 degree also. So it is a long period average. So you will have the average, and you see the departure, okay, how much variation is there in the temperature. So we use the climatology for seeing those differences or variability day to day. From normal, we compare those things. And based on those things, we mentioned sometime it is a cold wave or it is a heat wave. So likewise, based on those normal values, we can, based on the departure from the normal, you can define such type of thing. So similarly, for other parameters like rainfall or pressure and even wind, etc. So all meteorological parameters over a long period when they are average, so that is referred as the climate. So this, what is the difference between the climate and weather is that the problem of weather is neglect of details of daily fluctuation in the state of the atmosphere. So daily fluctuations will not be seen in the climatology. But weather, you will find, as I told, you will find lot of fluctuations are there. There is variation in the weather. Morning it is different, daytime it is different, evening time it is different. So those type of things will not be there in the climatology. The climatology, like temperature, as I mentioned, you will have some minimum temperature, the average value is this much during this period or during this day or on this day. Similarly, maximums during this time of this period, they will be of this value. So like that, only those things are there. But you see that the temperature, they vary from maximum to minimum during the 24 hours. And likewise, their observation time also, that is also different. Isn't it? So like that, weather and climate, you can define in simple terms like this. And then this weather process, if you are to capture it, so you have to observe first. So first of all, you have to take the weather observations. So this one observatory, model observatory that is shown. So here, what you see the boxes, they will have the thermometers. So maximum temperature, minimum temperature, then wet bulb temperature and dry bulb temperature. So this one screen that will have those things, and another one, same autographic charts also. Automatically that sensors are there. So they will plot also temperatures at every minutes and like. So those two are referred as a Stevenson screen. So in this, we place this thermometers, maximum thermometer, minimum thermometer, rival as well as the red one. So after measuring this, you can find out the dew point also. So those things we define. And for record purpose, generally you will measure every 3 hourly at observatory. Every 3 hourly we take the observations at class 1 observatory. There may be some class B or part-time observatories. They take morning and evening observations, and they may not be observing the all meteorological parameters. But a class 1 observatory, it will take all observation like temperature, and here another instrument that is a barograph. It is not shown here, that will be inside the building, in fact. So wherever the observatory is there, whatever office is there, they will place it there, and then you can find out the pressure. What is the pressure on that particular time when you are taking the observation. Other side you can see that is the self-recording rain gauge. That's a bigger one. So that is also an automatic instrument. It will give the graphical presentation or graphical information of the rainfall activity. Every minute or 3 minutes or 15 minutes rain, you can find out from this. And on this side, another one is that is the ordinary rain gauge. So every 3 hourly, observer will take the observation, whatever rain occurs in 3 hours. So he will measure it and then report it. So this is here, mainly you have temperatures and this rainfall measurements. Other instruments are, we have the, for the wind observation also, that instrument we refer as wind vane and anemometer. The wind vane will give you the wind direction, and anemometer will measure the wind speed. Those instruments we use for the measurement of the wind near the surface. And likewise, barometer, as I told, that we use for the measurement of the pressure. Other observation like cloud, etc., so that will be seen by the with the naked eye. will be seen by the observer, and he will report how much cloud coverage there and what are the type of clouds also. So they will be reporting all those information. So this is for a one station. So likewise, you will have number of stations across the country or across the globe you have, and those data, once they have observed, they will transmit it to the forecasting station, or you can say the central data collection center. Likewise, we have at our headquarters, and similarly, other countries will also have at a certain location their data collection center, and we exchange the data also, because whether it is not having any boundary, like you have the political boundaries, you are a different country, but whether it will not have any boundary, so we have to share the data. Otherwise, we cannot know if Pakistan does not share the data, meteorological information or data with us. So we will not come to know that some weather system is okay. So this meteorological data under the World Meteorological Organization, as per their standard operating procedures, this data is being shared. So this was near the surface. You can observe the parameters, and you have to report to the forecasting station. Likewise, we have now automatic weather stations also, and these automatic weather stations will also observe all these parameters. The only thing a problem with this is sometime a communication problem may be there, or some sensors may not work, so then you miss the data. But most of the time they are working good. So this also will give all the parameters like pressure, temperature, humidity, and wind also. But it will not give you the cloud. So cloud coverage, unless some observer is there, so it has to be the help of the observer only. So, but these parameters, pressure, temperature, wind, and humidity, etc., it gives. So this again, at the surface, we observe these systems, either the model observatories or synoptic observatories we call, and this is the automatic weather station. And this one, you see this balloon, after taking the observation near the surface, we need the upper atmospheric observations also, because that is the surface information about the weather conditions with the help of observatory. But if we have to see in the upper atmosphere, suppose at 1 kilometers height, or 2 kilometers height, or 10 kilometers height, or you can say within the troposphere. So what is the wind flow? What are the wind strength? If those things we have to see, and what is its direction also? What is the wind direction? So then we use this instrument. So this is called radio sonde and radio wind instrument. So with this, it is a hydrogen-filled balloon, as you can see it, a big balloon. And with this, you will attach the radio sonde. That sonde is an instrument which will have some sensors within it, like a temperature sensor and humidity sensor, and this wind, etc. It will be obtained through its trajectory, and direction also through the trajectory, and its rate of ascent, etc. So you will come to know in the atmosphere, in the upper atmosphere, what is the temperature at different heights, and what is the this dew point also, and then what is the humidity at different levels, and what is the wind speed and its direction. Those information you can get with this radio sonde instrument when it is released in the atmosphere. So it is being a hydrogen-filled balloon, that instrument is attached with the radio sonde, and once it is left, it is released, so it will ascend in the atmosphere. So it goes on ascending, and after certain height, it will burst. But we get observation up to 35 kilometers or so with the help of this radio sonde or hydrogen-filled balloon, and the radio sonde instrument attached with it. So with the help of this, we get the this temperature profile, wind profile, or humidity profile up to the height of even 35 to 40 kilometers. But our more concern is for the troposphere, because all weather phenomena, they are confined to the troposphere only. Beyond that, observation, so the information may be utilized for a temperature profile, how it is there beyond the troposphere, or what type of wind is etc. there. So that is further a thing for studies, but for weather observation, we need up to these heights up to 18 kilometers also. So with this instrument, those information again at different location, these uh, RSRW stations are there across the country. At present, we have around 60 stations, and they will give you the data of upper atmosphere, and those data again, the forecaster will analyze, or these data will go into the numerical weather prediction models. And this observation, it cost something around 20 to 30,000. This instrument and balloon and gas, etc. And the employees, they are separate, but particle count it will go more, but instrument itself, this cost around 20,000. So these observations are taken twice a day, one at 0 UTC, another we take at 12 UTC. That means at 05:30 hours IST morning, and similarly 17:30 hours IST evening. So those observations, both the time we will take and send it to the forecasting station, and then these data analyzed for the purpose of the forecast to be issued, and this data also will be archived also. They will be stored, and you can utilize it for the research purpose or research activities later. So after this, as I mentioned, at the surface, how we observe the weather, the parameters. Then in the upper atmosphere also, we have for such instrument. Besides this also, we may not attach this radio sounder to the balloon. We may simply release the balloon and find out its trajectory. So we can have only wind speed and direction. So that is called pilot balloon observation. So at 6 UTC and 18 UTC, these two every 6 hours upper air wind observations are taken. So as I told, at 0 UTC and 12 UTC with the help of this instrument, then other only wind profile pilot balloon that will give, it is taken at 6 GMT and 18 GMT. At those 2 hours, we take wind observation with the help of program. So only balloon will be there, that the radio sound will not be there, and it will give only the wind profile. So this is the likewise we observe. And beside this continuous monitoring of the weather, beside these observations, we have the radars also. So with the help of radar, we also keep the weather monitoring, to keep an eye on the weather development. So this radar, as you know, so it will emit the electromagnetic radiations, and through that scattering, you get the back scattered beam also, so that will receive, the receiver will be there, and it can give you the echo. What are the things which is developing in the. So this is one picture of weather observation on 14th October 2015 at 9:32 GMT. Means during daytime around 3 o'clock, you can see, or 15:00 hours IST. So at that time, you can see clearly, if you see this one, so here it is over the Haryana and Himachal Pradesh at this hours on this day, and we are getting these pictures continuously every 15 minutes. So you can see this weather system, these red colors or this heights, what you see, these are the clouds in fact. So this side you have this reflectivity, whether in dB, let's say unit. So here you can see more the reflectivity, darker color, this red color, and if lesser, then in this blue colors are there. So red color will indicate more water content or some solid precipitation also, like hail or snowfall. This lesser intensity, that will simply be rainfall or this water droplets. So this reflectivity will indicate, and this the height of the cloud will indicate what will be the strength of the rainfall. So what will be the intensity of rainfall, that you come to know. And with this type of clouds, this is during this October, and such type of systems are there when you see in the radars. And now, then you can find out, okay, such type of heights, 10 kilometer, 12 kilometer height of the cloud column. So that will give you good rainfall, heavy rainfall activity below this. So over these areas, if you see, it is a continuous line over here. So this is called squall line also. We call it a squall line. So this whole area having very intense cloud development and very good height of these clouds. So over this area that day, you will see very heavy shower will be taking place during this time. And simultaneously, there will be lightning or hail activity also. This type of a cell, they can give the hail activity also. The hail storm was observed on this day, in fact. So it is giving you that income. So now it is here, and we know the average speed of the system, what speed they move. So I can forecast that, okay, during next 2 to 3 hours, it will come over this Haridwar and Dehradun district. So Dehradun district will start within half hour, because it is approaching already close to this. But if it comes over this Haridwar, etc., we will find that it will take around 2 hours or so. Around. These system, in fact, they move with the average speed of around 50 km per hour. So you can find out how far you are from this. And during that day, it is the actual observation at night, that time when this cloud has developed. But on that day, you have already analyzed your observations or the information from the models also. What type of activity you are expecting, you are aware of it. And now this development has taken place. So you can say, okay, this system is going to come to my area. So based on those information, now you can alert the people. So in a shorter range, forecast for 3 hours, the people now cast for 6 hours, up to 6 hours now cast. So now you can alert the people that during that 2 hours or 3 hours, this weather system, strong weather system is approaching over the area. So you will have strong winds and heavy type of shower, precipitation. So people may take the precaution during that period. So this is the radar which we can utilize for nowcast purpose also, and it gives the very good information about the what type of precipitation or what type of cloud development is there, and what type of activity will be associated with it. So this Sam, the system has moved from there to here now. So you can see timing is 11:42. That was 9:32. So that means within 2 hours, it has moved from that distance to here to this distance. So if we measure, it will be around 100 kilometers. So they have a speed around, like I told, 50 kilometers per hour. So you have the surface observation with you from the observatory, then upper air observation from the reading sound instrument, and then you can monitor this weather system when they are developing and approaching towards your area with the help of the weather system. And beside this reflectivity, so you get the information on the rain also, how much rainfall it can give. And similarly, the wind speed associated with the system, also that you get some information on the wind also. Similarly, this is the satellite observation. So another tool for the weather monitoring is the satellites. So satellites, two type of satellites you generally have. One is polar orbiting and another is geostationary satellite. So geostationary satellite mainly we use because as the name suggests, geostationary means it will appear as if it is not moving. You can see from a point below the satellite, and you will see that a satellite is always at the same location in the sky. So that means it is a geostationary. How much time this Earth is taking in completing the rotation 24 hours. So similarly, this satellite, geostationary satellite, will take 24 hours in its orbit. So that means it will appear as if it is stationary. So that is why we refer it as a geostationary satellite. And the satellite, geostationary satellite, they have the height around 36,000 kilometers. They are very far away from the Earth, 36,000 kilometers. But still, the cameras or transponders what are there on board, so they can still give you the very good picture of the atmosphere or information about the atmosphere. So this is the one picture of a cyclone on 10th October 2013. So around 11:30 hours IST. So this you can see that a cyclone is there, large clouding. This formation is there, and you can see on this dot at the center, that is the uh, called we call it as the eye of the cyclone. It was a cyclone. So with the help of a satellite, you don't have, especially as radar we are having on the ground. So they can give you the, and they have the range 200 kilometers or so, and they can give the weather development information over this much radius, around 100 kilometer radius or 200 kilometer radius. But when you are far away in the sea, so you may not be able to see with the help of satellite, with the help of radars. But when the system comes near the coast, then you can observe it with the help of radar. But when they are far away, and beside this, over the ocean, the cyclone, when it is far away over the sea, then the only tool with us for it seeing its structure or its formation is the satellite. The satellite is very useful for seeing the large scale weather system. The small weather system, as I told you, a satellite is at a very great height, 36,000 kilometers. So a small system, thunderstorm, what you see here, may not be much visible in the satellite. What we showed this earlier one, they may not be much visible in the satellite, but they are very strong. We can monitor it with the help of radar. But when they are far away, so radar will not be able to see those things. But a satellite can give you the information about such type of system. So with the help of satellites, we can monitor, or we can monitor this weather systems over the ocean or sea surface, which are far away from the coast and we cannot see them. And similarly, over those areas which are not approachable, there also, with the help of satellite, we can see the weather movement of weather system. Satellite help very much in such situations. But of course, as I told, the small weather development will not be captured like that. So this day to day, every 15 minutes or half hour, you get this satellite imagery. So you can see the movement of the system, how it is moving, in which direction it is moving. Beside, of course, you will have the information from the models. They will also indicate you the path, and you need the forecast for a longer period. That is, this present, suppose cyclone, it is at this location, so where it is going to hit, whether it will hit over the Andhra coast or whether it will hit over the Odisha coast. So those information forecaster from his analysis and from the this numerical weather prediction models, So he has to find out those things. Okay, where likely, most likely is to hit the coast. So those information are to be provided to the administration so that they can take the precautionary measure and save the life. Otherwise, these days you can see that whenever a cyclone is approaching, so loss of life is very less. It is only in single digit due to the development of techniques as well as the development of numerical weather prediction model. So with the accuracy and the experience of the forecasters, so we are able to save the human life, a large number of human lives. Otherwise, when these cyclones were crossing over the coast, there were lakhs of people also died in some cyclones. But these days, these numbers you just find they are in single digit. So this one and similarly the same cyclone. It is on the 12th October 2013. So it has come here. Earlier picture was of the 10th October. Isn't it? So in 2 days it moved from here to here. So it finally crossed the Odisha coast. Isn't it? Those things were mentioned 2 days, 3 days in advance. So the people near the coast, they can be vacated and we can save the life. So satellite observation, very important, and it can monitor the weather systems regularly. But the only thing, some larger system it can monitor, not the small. So micro or macro scale type of system, it may not be able to, it will not be able to monitor. So another type of satellite here, you have polar orbiting satellite. And one more in this on this. So this was a picture of a cyclone, how it was moving. As I told her, you can monitor it with help of the satellite. So the project location, how it is moving, so that regularly, continuously, you can move. Similarly, satellite you can use for the monitoring the fog also. So you can see this is some winter during winter season. This fog is covering the whole Indo-Gangetic plain. These Gangetic plains are covered by the fog. So fog at a station, you will just see, okay, it is at my station or maybe in the surrounding. But with the help of satellite, you can visualize the whole area which is affected. So this information again, very much required by the aviators. So aviation industry, they require this information because when an aircraft has to operate, it has to be able to see the runway, isn't it? When thick fog is there, dense fog is there, it will not be able to land or take off. So it hampers the this aviation activity. Similarly, other things are also disturbed by this, like rail communication or similarly this other transport also. They are also affected by the fog. So with the help of this satellite, we can monitor these type of things also. And among the satellites, as I mentioned, we are mainly using more this geostationary satellite. Another type of satellite is polar orbiting satellite. So they also give the weather observation, but they will be giving once or twice over the same location. And their number is more also required if you want to continuously monitor the Earth surface over a particular area. Because as you know, when it will go from pole to pole, Earth keeps rotating, isn't it? The next time when it comes, it will be different. So its utility then is less. But it will be very close to the Earth surface. It is something at 800 kilometers above the Earth surface. So if you can see the Earth surface from such a small distance, then observation will be very good. But it cannot continuously monitor the same area because the Earth is rotating, this satellite will shift, also. So it will be monitoring different areas, but the area of interest which we want to monitor, we will not be able to do that. So for that purpose, we will need more number of satellites. Then they can continuously monitor the same area. Because that is a costly affair, till it is not achieved. But in the future, it is possible. So like this, we monitor the weather systems from surface observation to radar observation or from the satellite. After observing this, you have to give the forecast further that whether those things will sustain and when the cyclone will approach over the coast and likewise. And similarly for other areas as well, area of responsibility, you have to give the weather information by the weather activity by the clock. So weather forecasting or weather prediction, there are different ranges are there. So after monitoring the weather or observing the weather information, those information has to be analyzed with the help of some analysis and with the help of models also. They will also, this data will be given to the model and it will process those information and give you the output. Those output, we have to then assess whether this much will be there or it will be lesser or likewise. So accordingly, the forecast bulletins or forecasts are issued. So different range forecast we issue. One is the short range that will be valid for up to 72 hours, or it may be even for 3 hours, like the nowcast, very smaller range, or 6 hours. So likewise we give, or it may be up to 3 days. So that up to 3 days forecast that we refer as short range. That may be from few hours to 72 hours. Likewise, the next category will be medium range forecast. And medium range forecast, it is from 3 to 10 days period. So medium range means this we will mainly depend on the model output. 1 to 2 days forecast based on the present system analysis and seeing its past movement and seeing the present observation also how they are changing. So based on that, the 48 hours, here of maximum to 72 hours, you can use that information and you can give some good forecast. But beyond that, you will be depending on the model. So this numerical weather prediction models today, they are giving very good results, and those information we are using and issuing the forecast. So these days, in fact, short range forecast, we are giving the nowcast. I will say this for 3 hours or 6 hours or for 24 hours. But instead of this 3 days, we are giving up to 5 days. So that means a short and some medium range we are covering. The present date, this forecast, etc., what we are issuing, this is only for 5 days. And with that 2 days outlook also next, 2 days outlook also we mentioned. And accuracy also good, up to 5 to 7 days accuracy is good. Then you have long range forecast. It is more than 10 days, that is referred as the long range forecast. So extended range forecast, that is also being issued for 20 days or up to a month. And that is also being given. And further, we, among the long range, we can say for a month or for a season. So among the long range forecast, the IMD monsoon forecast comes along this long range forecast category. So there you give the forecast for the whole season, monsoon season, and what average rains you are expecting during the season. So that is the long range forecast for monsoon what IMD issue. So these are different ranges. Once you have the observation, we have the models. Those observations will go into the model. We analyze also. We have analysis system with us. And based on all that, we are to prepare the forecast. Either the short range forecast, medium range, or the long range forecast. And this is one example here. You have suppose these observation at different location. You can see these are the observation, and I have analyzed this over Indian region for the pressure pattern. So these are the impact isobars at 2 millibar differences like that. So with the help of this, you can find out where higher pressure is there, where lower pressure is. Pressure is low, and where pressure is high. So low pressure system. Just a minute. सर उनका खुद ही फोन आया था जो डायरेक्ट वाले और उन्होंने लेटर भी इशू कर दिया है और मैंने ये खुद बता साइंस आपको और तो 2 तारीख को जाने का है जी को जो सर मेरठ वाले हैं हाँ पहले भी तो गए थे सर लेकिन आज उन्होंने फिर से लिखा उसी उनके डीजी ने बताया वो भी बता आपको भेज देता हूँ हाँ उन्होंने सर जैसे लिखा है ना तो उन्होंने वही लिखा है कि पहले में और बाकी हम लोग को एक बार बात करें फिर उनसे अभी सर बात अभी थोड़ी देर पहले ही की और अभी हम उनसे फिर से बात कर रहे हैं कि आपको कौन कौन अधिकारी वहाँ होंगे मीटिंग होगी तो वो पता कर देते हैं कभी फायदा चाहते होगा जी सर ओके ठीक है सर ओके सर ठीक है सर तो एक लेटर भी और मैं बात भी कर लेता हूँ ये एक लेटर भी दे देते हैं कि आप यहाँ से लिया है यहाँ किया ही है आप समझा ठीक ठीक है सर हाँ उसी की बेस पे कर रहा हूँ बात जी सर मैं सर सर ठीक है सर नमस्कार सर Sorry. So this, am I audible? Hello.
Yes, sir, audible.
Okay.
Audible.
Okay. So this I was mentioning that this once the observations are available, how we analyze. So this pattern if you see was analysis done for the pressure pattern, and you can find out with the help of this analysis where the low pressure area is there, where the high pressure is there, and as we know, the weather system are associated with the low pressure area. So wherever that I think you find out, you will find that over that area, some development will certainly take place. So based on that, and based on the intensity or this gradient, etc., and seeing its extent in the upper atmosphere also. So you will analyze also the other levels also. This is at the surface. We analyze it for the surface observation for the this pressure distribution. Similarly, you can analyze it for the temperature distribution or the wind flow, etc. Streamlines. So this information will give uh, information about this analysis will give information about pressure system, where is the low pressure system is existing. So we are concerned more with that. Bad weather will be associated with the low pressure system. And similarly, we will see that the system, how it is extending in the upper atmosphere. So this is the wind in fact, the wind observations at something 1 kilometer high. So you have to draw the streamlines for this. So these streamlines will indicate how the flow is going. Okay. But okay, this observation you may not appreciate because you are not aware what are these signs indicate. But this is the this wind impact. So this wind bar, 3 bars will be for 30 knots and likewise, and this bar will give the direction. So from north to direction, 30 knots winds are there. So likewise, how it is, we are not to cut the winds, we have to go as a tangent and find out whether circulation is taking place or anticyclonic circulation is there. So when a circulation is there, so that means over that area, some development is possible. So this is the analysis of various weather parameters at the surface or in the upper air. So likewise, you can see these things. These are also observations, some observations. Likewise, these are also wind observations. And you can see some formation. If you see the circulation also in the wind or some type of thing, means a low pressure region. So over that area, you will find some weather development is there, clouding is developing. And at higher levels, what are the winds or jet streams? That also you can find out when the jet stream is moving. So it will give you the information on strong winds and its location. And below these jet streams also, some good weather activity takes place. So you have to see all the parameters at different levels from surface to upper air up to this 200 SP if I tell. So that means at the 12 kilometer height, around 12 kilometer height, what are the wind flow, etc. that you can see. So taking all these things into consideration, and for this we call synoptic type of analysis, synoptic meteorology, and then you can have dynamic meteorological information also with you, tape, sign, all those parameters, how this energy is there, how much energy is there with the system. So those things you can find out. So with the help of these, you have to forecast what type of activity one can expect. So this is something on the weather forecasting. And here another one. So these were I was mentioning, it is the actual observation. We will analyze them and then try to give the forecast. But at the same time, now numerical weather prediction models are also with us. So we will match our assessment and what this model predictions are giving us, that also we will do. And this numerical weather prediction models, they are based on this whole dynamic meteorology or physical meteorology, and they are mainly those numerical weather prediction models, whatever are developed. They are based on these three basic laws of physics. One here, law of conservation of momentum. Similarly, you have law of conservation of mass, and then law of conservation of energy. So with these, you can develop the equations. And these equations so developed are the partial differential equations and solved by applying numerical analysis techniques to find an approximate value. So people ask that weather prediction, why it cannot be exact. This is the answer. you have the partial differential equations. You do not get the exact solution of the equation, but approximate value you do get. So you can give some idea on the intensity. This will be intense system, or this will be light system. But exact value telling that this was only will be the rainfall, you cannot say. You have to give some range because there is approximation in the solution. That is the reason that weather prediction, so you may capture the event well, but still, what is the intensity of rainfall, how much exact rainfall, you cannot tell. You may give the some range that it will be heavy type of precipitation, you may say, or you may say there will be strong winds during this period. But what exactly will be the value? You have to give always the range. So based on the, you develop the 6 equations based on conservation of momentum, conservation of mass, and conservation of energy. And those equations you have to solve with the supercomputers, isn't it? That means some programming are done in the computers, and over the whole globe you have the observations, and at a different grid points you will put those observations, and then from those observations actual values you will put it to the every grid point. It will depend on your model, what is the grading you have done. But actual observation, you have to transfer it to the grid point, and from there you have to fill the all those grids also, grid points also, which are not having the observation, isn't it? So like that, those observations will be developed, and after that the model will process it further and will give you the output, and the output will be all these parameters again. It will give the precipitation, how much likely precipitation is expected. Similarly, it will give the wind flow pattern, what type of wind flow pattern and what the circulation, etc. Is there. And similarly, what will the pressure pattern like. So it will give all those parameters, what you have given the information, same parameter will give them as a output also. So numerical weather prediction model, these days we are using GFS and WRF models, and they are giving the good results. So these things are being done for numerical weather prediction. So from there, whatever information you get, so those have to be analyzed, and final forecast or bulletin has to be prepared and given to the concerned authorities. And next, so weather prediction, I will say observation and prediction up to this one. Next, we will take it to the this climate. So climatology also, as I told, weather and climate monitoring and prediction. So among the climate for Indian prospect, in respect of India, if you talk, so these seasons we have: winter season, pre-monsoon season, then southwest monsoon season, and northeast monsoon. So winter season or winter climatology, during that period, what type of things you observe? So you have the rain and snow, likewise cold wave conditions, fog, or sometimes thunder and hail also. So during winter season, weather activity generally you will get over the northern parts of the country, northwest India or northeast parts, some northeast parts also. And rest of the parts almost remain dry, very few activity, very less activity. And some activities over the south peninsula region you get during the winter season due to movement of easterly wave. Similarly, you have another season, pre-monsoon season, which is from March to May. This is referred as a hot weather season also, summer season also. So during summer season, mainly we have the thunderstorm activity, or when those type of things are not there, so you have the heat wave conditions or high temperatures. And similarly, during pre-monsoon season, there will be development of the cyclonic storms over Bay of Bengal or over the Arabian Sea. So those things there you can observe also. And those cyclones or depression which forms over Bay of Bengal or Arabian Sea, they come towards the coast, either east coast or the west coast, but more they come over the east coast. Formation of a cyclone or depression, it is more over the Bay of Bengal compared to Arabian Sea. So, and cyclones, they are bimodal. They forms in the month of these pre-monsoon season months, March to May, or again they form in the post-monsoon season. That means from October to November, or sometimes December also, October, November, they generally occur. And these cyclonic storms, they do not form during winter season, and they do not form during the monsoon season also. So during monsoon season, they don't form due to high wind shear. So development, some development may be there up to depressions or so, but not beyond that. They do not go to the intensity of a cyclonic storm. Then we have the southwest monsoon season. The southwest monsoon season or the rainy season, what we call, it is from June to September. And during this period, you get the maximum rainfall activity over the country. So, India has a maximum rain that occurs during the monsoon season up to 80% rainfall activity. It is during the monsoon season. And rest 20% over the year, that is during other season. The maximum rainfall contribution is from the southwest monsoon season. And that is why this Indian economy depends maximum on the monsoon rains. So monsoon rains during that season, whatever crops are there, it is required for those, as well as they will recharge our resources and reservoirs, etc. You get the plenty of rain reservoirs also, and for those reservoirs or dams, they will utilize it for electricity production or for irrigation purpose also. That water will be used. So monsoon season is or monsoon rains, they are very much required for the Indian economy. Then afterward is the northeast monsoon season. The northeast monsoon season again, once the monsoon starts retreating and northeast monsoon set in, and that northeast monsoon will affect over the south peninsular region, mainly the Tamil Nadu, Kerala, or some South Andhra, Rayalaseema, that will be the northeast monsoon. So during these seasons, if we see the average climatic condition pattern, so these components of climate if we take, that is pressure, wind, temperature, precipitation, and weather system. So among these season, as I mentioned, first you have the winter season. That is from January and February we take. Of course, the winter over north, it starts from December itself. So if you see the pressure pattern over the country as a whole, so what you will see is during winter season, you have the high pressure over the land. And center will be somewhere over the Rajasthan and neighborhood, those areas you can see. And that high pressure belt will run towards the Bihar. So now you have the high pressure over the land and lower pressure will be towards the sea area. So that means wind will be going from land towards the sea. So that means there will be less moisture. No moisture is there. So that is why during winter season, you get the less rainfall over the country if you take a country as a whole, except you leave the northwest India, which is affected by the western disturbances. So western disturbances, they develop over a Atlantic or a Mediterranean Sea. From they move eastward and give some weather activity over the northern parts of the country. And when those WTs move, if they are strong enough, so they change the wind pattern at the lower latitudes also. And a formation of induced system also takes place. So when induced system is there and the WT is also there, so that time you get some rainfall activity over whole northwest India or even up to Bihar and the northeast states also. So during a winter season, otherwise, you have the high pressure over land, winds will be from land towards sea. So some idea if you have of the cyclonic circulation and anticyclonic circulation, around a high pressure, it will be anticyclonic circulation. And around the center, if you go anticyclonically or clockwise in the northern hemisphere, so you will find that from Rajasthan to Bihar, a line if you draw, south of this you will have wind as a northeasterly, and north of it you will have northwesterly. And wind speed maybe 5 to 7 knots or sometimes also 10 knots even. So that type of wind you will observe over the country. Similarly, temperatures, if you see, so temperatures also, the distribution, it maximum temperatures will be over the Kerala or Tamil Nadu during winter season, and they will be minimum over the Jammu and Kashmir. When you come from south to north, temperatures goes on decreasing. And precipitation, as I told, during winter season, northwest India gets some rainfall due to movement of these western disturbances, and some easterly waves move over the south peninsula region. These areas mostly get the rainfall. Rest parts of the country receive some local activity sometime, or there may be some formation of a depression, etc. over the sea area. They may push towards the coast. Then some activity may be there. Otherwise, most of the portion of the country remains dry except the northwest India and the south India. That's some system move. Similarly, as I told, you have the high pressure region over the land during the winter season. And if you go over the monsoon season, it will be just reverse of this. You will have low pressure area over the Rajasthan and neighborhood. That is very intense low pressure system. And as you go away from this, the pressure will be increasing. So where you are having high pressure during the winter season, now during monsoon season, you have the low pressure system. So that is the change we get from winter to monsoon. These only two circulation effects are there. So during monsoon, when low pressure is there will be anti-clockwise circulation around it. So winds will be coming from sea towards the land. They will bring lot of moisture over the land and good rainfall activity. And in between, from winter season to monsoon season, you find the transition. That is called this pre-monsoon season, also transition season. And likewise, post-monsoon also transition season. So these things are there. Likewise, it happens. And quickly we may move further. So some idea on the climatology. Okay. And weather system, this first slide I just mentioned different weather system which occurs in the different seasons. And here this for the Uttarakhand, etc. You can just see. And this is a normal rainfall season, the monsoon season. Even maximum Dehradun and Almora season, less rainfall. And likewise, if you see during the monsoon season, Uttarakhand gets the maximum rainfall. And adjacent states, they have very less compared to Uttarakhand. Uttarakhand is receiving very good rain in the month of monsoon season. And even annual average also, Uttarakhand has more, other states are less. And similar this, you can see the for 20 years, this is monsoon data. And if you see this one is the average rain during the monsoon, this is excess, this is plus minus 19% taken within the normal. So this line to this line, this is the exact normal, but this to this we will take within normal. For certain years you have above normal, and other years you can have some below normal also. So likewise, this is last 20 years climatology of the monsoon season. And whenever there is more rains, so casualties are also more. That is also seen. And this also one information on the monsoon season. Whenever you have normal monsoon over the country, Uttarakhand also has the normal monsoon, except one we have two when it was not deficient here, normal, but we have the deficiency this side. 93% probability of normal or excess rain in Uttarakhand when monsoon is normal in country as a whole. So these things are there. I think quickly I just can show this is the climate system. You might have seen other authors also might have shown these things. So sun is the ultimate source of the energy, and here water and these things, plantations, lithosphere, or this ocean, or this troposphere. So this sun is the source of energy. It creates differential heating on the surface, and due to that you will have differential pressure, and pressure will generate the wind. So wind, when it is from water bodies or from sea towards the land, you will have rainfall activity. So likewise, this rain again evaporates, goes in the atmosphere, forms the cloud, comes down as the rainfall, and this rain again comes down through the rivers to the ocean. There is a cycle. You might have seen these things. And on the global basis also, this climate observations are being taken. So for this GCOS, this is the organization which will monitor the climate globally. It is taking these observations, observing it, archiving. So atmosphere, ocean, land, and space. All these four places. This is GCOS is taking the observation. These are the number of observations. So likewise, this is for the surface network for different reasons. So these stations data they take for climate studies. And this is the upper air data being taken from these stations for upper air atmosphere study for the climate. And this is over the ocean or along the coast also. They are taking those observations to see the rise in the sea surface or what are other changes also. So number of parameters they are measuring. And this is some pictures earlier and now. So this ice melting is showing. And this depleted sea. And this again on the human activities, how this carbon emission, etc. And due to that, how these temperatures are increasing. Greenhouse gases are increasing. So different gases, earlier one, and after this time, how rapidly they are increasing. These greenhouse gases. And this concentration of carbon dioxide increases in 1950 due to human activity. Also decrease ozone concentration over the polar regions. And carbon dioxide, greenhouse gases, or chlorofluorocarbon, those were increasing, and there was the effect of those emissions. And this is the temperature series for the global warming. If you draw a line, so you can see it is continuously increasing. But now for some years it is being seen that it is constant, not continuously. But already that increase which has taken place. This also global average temperature anomaly. So global mean temperature around 0.6 degrees Celsius, it is rising on an average. And this projection is for the climate projection for ice over the Arctic Sea. So it will be around 2050 or so, it will be of ice. That is the projection IPCC has given. And this is a reference to the Indian region, Central India region. Earlier, heavy rainfall frequency was less, but now it will increase. So 15 centimeter or more rain, the frequency is increasing. So this is the summary. Due to increase in greenhouse gases, global warming takes place. Observations suggest a warming of 0.6 degrees C per 100 years. Simultaneously, many other changes are also needed in the climate system like sea level rise, Arctic ice melting, etc. With the mathematical models, climate models, future climate is projected, assuming some emission scenario. So this present emission of gases, if that continues, what will be the climate after certain period? So that the climate model, this is being shown. The climate model suggests continuous global warming, but Indian monsoon rainfall is going to be increased. So thank you. This is all from my side. Thanks.
Thank you, sir.
Thank you.
Participants, any query? You can also send the queries through mail.
So thank you for giving this opportunity, and I wish all the best for this 3-day webinar. One more day is there. So thank you.
Sir.
No more
Thank you.
queries? Okay. Yeah.
Thank you, participant, for joining today. Tomorrow we'll resume morning at 11 a.m. Thank you.